Okay. Hi guys, I am Bharat Kumar, and along with me is my colleague Pavan. So we are going to talk about next level CI in the sense what does a CI really need to have for it to cater to our needs, community needs, and we are going to go the way about we are implementing it, and then what are the challenges we saw, and the ways which we have implemented it. And at the end, like Pawan will go, he was testing the results that were coming out of a CI, kind of validating whether it was because of an environment issue, test issue, because early on we were not sure whether it was because of the way we set it up or it was a test issue. So he'll be presenting some of the issues that we saw in the tests. So when we thought about doing a CI, we just thought like what is the minimum or maximum that we could do to build a CI. So first off, our thoughts were like it should be completely automated, in the sense once it is set up, people need not go and tinker with it. It should just keep looking at the PRs and keep testing them, posting the results. It should be fully automated in that sense, and then it should be able to test multiple PRs at the same time. Cause presently, if you see, like in the community, there were about 200 odd PRs that needed to be tested, and if you just only test one PR, it probably take a long time to get through all of those there. So the idea was to be able to test multiple PRs at the same time, and then execute tests in a parallel manner rather than executing one after the other. So after all the thought process, we started developing it, and the present state of the CI is like these are the features which it supports as of now. So it's completely automated and it can work on different hypervisors. So as of now, we only support KVM and Zen, but we plan on adding support for VMware and Hyper-V as well. And we have a GitHub integration that goes and looks up all the PRs that are there, which are not tested yet or which have been modified, and then these get queued up in the test queue. So every time it gets triggered, it looks up if there is any test in the PR in the test queue, and then starts executing tests. So in order to run parallelly, if you run too many tests parallelly, what happens is you are in a risk of running out of resources, because each of the tests creates its own network, its own VM, and it also needs a couple of IPs. So we have seen like you could run out of resources. So there is a need of batching the tests such a way that you run 5 at a time or 6 at a time, depending on the amount of hardware you have added to the CI. So that way we have a manner of specifying batches, test batches, and also the tests that we need to run. And another thing is like while running parallelly, you don't want to run two conflicting tests at the same time. For example, if there is a test which is trying to check for register volumes, but if you start running an SSVM test which restarts the SSVM while the volumes are getting registered, that's a problem. So we need to have a way of telling the CI that don't run these two tests together. So we have that as well, a manner of specifying how to run, how many to run, and what to run together, what not to run together. So that's there. And then dynamic loading of tests. So what happens in the community is like people keep adding tests, and we don't want to go and keep updating the list of tests that we want to run. So what it does is basically goes and checks, because in CloudStack the test folders are pretty static. We just go to them, check whatever tests that are there, load them, and then start executing. So it kind of dynamically loads any of the new tests that are getting added. And then auto seeding of system VM templates. So while setting up the CI, you just tell it like from where to get the system VM templates for a given version of CloudStack. It will go pull the system VM template from there, and it will seed it so that the proper version of system VMs are getting launched. And then coming to the test log management. So when the CI runs, it generates a lot of logs, and each of the tests is kind of gives us three files. So one of the file contains the exceptions, the other one the run log, and there is one more which will tell whether the test was successful or not. But that's all grabbed from the XML that gets generated. So what we're doing is like we're collecting all the test logs, bundle it, and then put it on Dropbox for people to download and see if something has gone wrong. That will help in debugging. So we bundle in the management server logs as well. And the test run analysis, so we are planning to do a lot more over there, but currently what we have is like it will look at test runs, see if some of the tests has failed in the past, and that too continuously. It will say like it has been failing since so many runs. Now how is that useful? Supposing if you see a test fail only for one time or two times, probably some of the code went in just then. If it fails repeatedly, maybe there is an issue with the test, or bad code was already crept in. So that way you can that way it kind of tells you to go look at the tests which are failing pretty frequently. So that's one thing. And then scalable and extensible. So most of the components of the CI are from open source, and they are pretty modular, so it can be scaled whatever way we want to. So these are the components of the CI which we have. So there is a driver VM, a Jenkins server, infra servers, and then server farm. So I'll be explaining each of the components in detail. So this is the high level view of how these things are connected. So coming to the driver VM, so I call it driver VM because once it gets a trigger from Jenkins, this is the one which goes and orchestrates all the test setup, runs the tests, publish the results. It also has utility servers like Cobbler and Puppet, which help us in creating the CloudStack setups. So this is the one which drives the entire test run, and it is also a Jenkins slave. So Jenkins server, it's pretty common. Most of the people use it for triggering the test runs. So we do the same here. And also we create dynamic test executor jobs. Just a matrix job on Zen server, which we load with the test which we want to run. It gets created on the Jenkins server, and it starts executing the tests. So we use Jenkins mainly for executing tests, triggering the tests, and then viewing the test logs. So infra servers. So infra servers means we need to have a set of servers where we want to launch CloudStack management servers. So these are these basically can be any hypervisor. Currently we are using Zen. So it has a script on top of it which goes and launches a VM whenever there is a requirement. Driver VM goes and triggers that particular script so that management server VM is launched. So once the VM is launched, the Puppet server and the Cobbler server kick in. The Cobbler server does a PXE boot. Puppet goes and installs a dev environment on top of it. So once that is done, the driver VM sends further instructions to image the host. So it goes and talks to the server farm. Server farm is just a set of IPMI enabled hosts to which driver VM can talk to. So depending on the type of configuration that we are using, it will look at that and it will go and image the required hypervisors. Supposing we want to create a Zen server based setup, it will look at the configuration, see like, okay, the hypervisor type is Zen server. So it will configure the PXE settings in Cobbler so that when this particular machine is restarted, it will start PXE booting and it will boot Zen server machine. So we use a server farm, a collection of servers which are IPMI enabled, and each of the IPMI NIC needs to be reachable from the driver VM. And we are using NFS server to store the test results, logs, as well as we use it for the workspace for Jenkins, because whenever you create jobs, it kind of creates a new directory in the workspace, and it requires quite a lot of space. So we are using NFS server. We create directories on top of it and mount them at specific locations inside of the driver VM, and also all the PXE boot images required by the cobbler VM are there on this NFS server. So these are the network requirements that are there. So the driver VM needs to be able to talk to the server host and the server farm. So all of these need to be in one subnet for it to work. We need one subnet to allocate public IPs from to be used in CloudStack setups, and one IP from the and couple of IPs from the private subnet. So we are going to keep that as the same as the management subnet. So we allocate IPs from the management subnet onto CloudStack, and then we need a couple of VLANs for using CloudStack, and all of the VLANs need to be configured prior to running the CI. So what do we need to set up this particular CI? So currently it's not automated. So we need to create a driver VM from one of the templates, then configure the cobbler server on the driver VM, set up a Jenkins. We have got XML files to describe the jobs that are required. You can modify them slightly as required, and then you can populate these jobs into Jenkins server. So once that is done, you need to, there is a DB which the driver VM uses to getting the IPMI IPs, the MAC addresses of the host. So you need to add that information in the DB, and also add information about what configuration we are using. So after that, we need to go set up the mount points on the NFS server and mount them at specific locations on the VM. So this is what you have to do. Once you're done with these things, you are all set. You can run your tests. So the hardware requirements, these are the minimal amount of hardware that is required. So 3 servers, of them one for hosting the CI components, and the remaining 2 for using CloudStack setup. So I'm saying 2 because there are some tests which try to test migration. So there needs to be 2 clusters. So each of the cluster can have 1 host. Then a couple of private and public IP ranges and VLANs. So scalability of the CI. So Jenkins server is pretty much modular. You can create whatever jobs you want and then tie it together with the main job that runs on the driver VM. So that particular job takes a lot of arguments, like what config you want to build from, what is the repo from which you would like to pull the PR, what is the PR number, things like that. So depending on that, you could set up your jobs. That way you can cater to different kind of workloads. Supposing one case could be like you just want to go test the PRs, so then you need to just give the GitHub URL, and then you need not specify which PR. It will go sync all of the PRs that are there in the GitHub onto the local DB, and it will start testing one after the other. So supposing if the driver VM is full, kind of running a large number of jobs, you want to scale it, what you can do is simply clone it, add it as a slave in the Jenkins, and Jenkins will take care of distributing the test runs across these 2 VMs for us. So that way it will scale horizontally. And then setting up in different ways, meaning like supposing there is a use case of distributed CI that most of us are talking about. So you can have a job configured to split the number of test cases that you have, and then pass each of these as parameters to the sub jobs, and each of the jobs can then be tied to a particular slave VM. So that way you kind of can realize the distributed CI thing as well. So that way it's very flexible. And so this is the roadmap which we have. So currently, as I said, the setup process is not automated. You need to do a lot of stuff manually. So the idea is have a vagrant setup which we could use to automate creation of the VMs, and then configure cobbler, puppet, depending on the configuration file which we'd specify. So that way it becomes more usable, by the community. So as I said, like, we want to add support for VMware and Hyper-V as well. So we have worked a bit on the VMware side, but Hyper-V we need to explore. And then I was talking to Will as well. He also has the similar idea of test cataloging. What I mean by this is like, supposing there is a PR which only has changed the storage code, but you don't want to run all of the tests. Some of the tests may not be relevant in that context. So you'd like to get a list of tests that are relevant to that PR. So this can be done two ways, like either we maintain a catalog which says like, if a guy has modified this particular folder, go add these tests and then run them. The other way around is like what Will was saying, have an orchestrator figure out what are the changes from the diff, and then go see like what are the test cases that mattered, and then add them. So that's one way. So we were thinking more of the catalog way. And the other thing is like, so currently there is no way to tell what hypervisor do you want to test the PR. So we are by default testing it against Zen server. So but what we'd like to see is some structure in the PR title, so that you can say, you can add tags saying like run this PR against Zen server or VMware, and the CI should be able to look at the title of the PR and then decide, okay, the tag says like I need to run on a particular type of hypervisor, so it should go and create that particular setup and start running. So these are things that we'd like to do as a part of the roadmap. There's a lot more that we need to do, but this is where we are now. So the major goal is to make it consumable for the community, so that people who want to run their own CI, they need not go build a CI of their own every time. Like, so if it's easier this way, so we want to like package it and then provide it like a CI system for anybody who wants to use it. So now I'll hand it over to Pavan. So he'll speak about some of the known test issues which we have been seeing in our runs.
Hey, so recently we had some failures when we have run our CI against some PRs. So majorly, like we had some of the test. This is not obviously an exhaustive list. So some of the major tests that were failing frequently. So, and we have already worked on some of those and fixed a few of them, and a few of them obviously needs to be investigated. So we would obviously have the guys over here to work in hackathon today probably and fix some of these if possible. And so if I have to list out few of the issues, so some issues we have faced were related to test scripts where they were probably grepping for ping. So ping to outside world was failing because they have written tests in such a way that they were grepping for a specific string. So let's say they were grepping for 3 packets received. They were doing a count of 3, and in some operating systems it was like 3 packets received, and in another one it was like 3 received. So some of the tests were failing because of this. And some issues we have seen, like people are configuring the storage related things within their scripts rather than having them organized in the testdata.py file. So it would be good if all the configuration goes into the testdata.py rather than having them cluttered in your own script. And some of the other issues or probably improvement we have seen is like if someone has written a piece of code, and they have written Marvin tests for that code, it happened that they have raised 2 separate PRs, one for the Marvin tests and one for the code itself. It happened that the Marvin test PR got merged earlier, and it got executed and it failed, so that the code was not over there. And some other issues that I can think of are related to templates, and these needs investigations. And the other thing, as Bharat has mentioned, when we had resource scarcities, we were running everything in parallel. So sometimes it were passing and the other times it were failing because the IPs got consumed if they were released and the tests were passing. If they were being held by some other tests, it was failing in some other cases. So in order to address that, we, as he told, we were using batches so that we execute a few tests, and so that we consume only little amount of resources and then go to the next batch. So this is more or less the failures, and we are still working on stabilizing the test scripts, so that we have to make sure that the issue is with PR code, not with the test scripts. So that's all from our side. If you guys have any questions, we will be happy to answer.
So, is there a way to run your CI environment without the need of coupler, without the need of using coupler? Is this mandatory to use coupler, or we could use something else to?
So currently it's kind of tied into the code which we have, but you can definitely, with a little modification, you can use Ansible maybe, or sorry, not Ansible, any other thing other than cobbler. You could use your own Pixie booting mechanism if you want to.
Okay, thanks. Anyone else would have some question? Yeah.
So for people writing new tests, how would they show whether their test can be run alongside other tests? Because you said you have to work out which ones can't be done in parallel. How does a new person mark their test that it can't be done in parallel with specific other tests?
So ideally there is no restriction on having to do that. Whomever is writing test is expected to write it in such a way like it should run in parallel. That is the expectation. And for the same reason, like what we have is each of the tests creates its own network, creates its own VMs, it has its own account, so that it doesn't conflict with the rest of the tests. So that's the way we have been writing tests to run them in parallel. But the main challenge has been with the shared resources. So what happens if a particular test wants to use a particular VLAN? Supposing, say, it's using 200, and the same test, another test, which is also trying to use a VLAN, it will try to get a VLAN 200, say, because it's already in use, it can't get it, and so we see a failure. So one way of handling these things is like, while writing tests, define what are the resources that it needs, and then add them into the testdata.py, and make sure that none of the other tests are accessing the same piece of shared resource. So one way to do it is like make some modifications in the framework or so that if a particular resource is in use by some other test, either you see like if there is something available that can be given to it, or you say like there is no resource, so I'm skipping the test run. So that way it will not be a red flag. At least you'd come to know like, okay, this did not run because there was not enough resource, so you could add more of that. So those are the ways which we would like to solve these parallel execution cases.
Anyone? Any more question?
So just to understand, so you currently have a pool of hardware that you effectively rebuild currently for each test case or group of test cases you run. So you build a KVM environment or a Zen server environment out of a pool of hardware. Do you have a fairly large pool sitting in the background of spare hardware for this? Or
So
in other words, how many tests can you run in parallel at the moment?
yeah, so so with the minimal configuration that I have mentioned, so you could run about 6 of them in parallel, but if you got more hosts, say 4 or 5 of them, you could go up to 13, and that would work. So it's all dependent on the amount of hardware you have, and it kind of translates into the number of tests you can run in parallel.
If you have enough hardware, there's no issue of these parallel resources.
How about timing for spinning up environments? So
Yeah,
if you hit go, how soon do you currently manage to start those tests? How long does it take for environment to build?
Yeah, so you mean to say test 1 PR?
Yeah, so if from you hit go, whether that's Jenkins or you do it manually,
Okay.
to you have the environment up and running,
So
and the first test is able to run, what was sort of turnaround
Right.
time?
So approximately like what we're doing here is like we are trying to build a development setup on the management server, and we are trying to minimize the amount of time it takes to get the management server up and every time. So what we're doing is like once a management server is up, we store the details of that management server in the DB, and we tie it to a particular configuration. So next time if someone is using the same configuration, we'll see like there is already a VM and that's already ready and set up. So we just go to that particular VM, pull the new code or whatever PR we want to test on, build the management server, and then start testing. We create the setup and then start testing. So it all in all, like it takes about 40 minutes for the setup to get up and running, mostly because we need to do git pull. Git pull is pretty fast sometimes it's slow, and then the build time, it varies depending on the management server settings, like how much CPU you're giving to it, how much memory. If you're directly copying the empty repo, time will come, it will be even less, but copying is not advisable, as in you will not get the latest ones from the Maven Central. So the build time is approximately about 10 minutes, and the major time that we are seeing is like once the setup is up, the system VMs need to start. Now if your storage is pretty fast, supposing copying from secondary to primary doesn't take a lot of time, the system VMs may come up in say 5 or 6 minutes. But if that is slow, it will take quite a bit of time for the SSVMs to come up, agents to be up on both of them, and only we check for those kind of things before initiating a test run. So all in all, it about 40 minutes.
And as for the test execution, we are currently working on improving the BVT test times as well, because we have seen that a lot of virtual machines were being up and being turned down during the course of the tests, which were sort of, we felt, redundant. So we are currently working on a PR internally, and we will be pushing it into ACS pretty soon. So we will be able to reduce even the BVT execution times to probably some 2.5 hours.
And so one other issue which we were seeing is like in the Marvin framework, wherein if it fails to clean up one of the resources, if it throws an exception, it just comes out of the cleanup loop, and what happens is it fails to clean up the rest of the resources. Now they are kind of stuck. The rest of the tests can't reuse that resource, and it keeps piling, and because of which the next tests which are going to run, they fail because of lack of resource. So that's also one area that we'd like to improve on.
What about versioning? So if I wanted to go and target, say, a specific Zen server version, say 6.2, with a specific CloudStack branch as opposed to just master, how is that going to work?
So there are parameters where you can specify what is the repository, what is the version from which you want to run your create your management server, and then you can also configure cobbler so that it is set up with 6.5 PXE boot than the Zen server 6.2, and then you can specify that in the configuration file, saying like this is the version which I would want to use. So it will go and create what it does, it just creates a system, a cobbler system, and then associates it with a required profile.
So does that also extend to, so taking 6.5 as an example, if I wanted to test against base 6.5 or 6.5 SP1 or some hotfix, is that, do we go that level of detail?
So we could go, but presently what we do is we pick one standard Zen server template that works for all, and we are kind of testing on that, but you could go do that way as well because it's configurable.
Cool, thanks.
So from what I understood, the configuration is static for the whole run or for the CI, or we'll be able to tweak that on a per PR request later?
So the configuration mostly contains of what hardware that needs to be used, and depending on the type of hardware we go and hardware, we can reimage that hardware into required hypervisors. So that's
but
how
that configuration is static for entire run,
the
entire test run, or it's static for the whole CI? So all the PR then onwards will be using that hardware. Can I say for one PR use Zen server 6.5, one for 6.2, another PR for 6.2?
Yeah. So what you could do is like you could create two Zen server jobs in the Jenkins, and you could specify a particular configuration file. Each need to have two different configuration files, which will say like run this particular trigger this job with these parameters, and the other job will get triggered with different parameters. Based on those parameters, we can go and create the necessary setup.
Okay. Thanks.
So as he rightly asked, like the presently configuration and the type of hardware we use, it's kind of static. We don't go dynamic resource allocation. Like you have a pool of hosts, you pick a few of them depending on the availability. We don't go that way. We wanted to make it more simpler, as in you can create static configuration files which refers to each of the machines that you would like to use whenever that particular configuration is called for. So that way we only check if a particular configuration is in use. If it's not in use, we go ahead and use it. Otherwise, we simply bail out saying like the configuration is not available at this time.
Other question, anyone? I think we're good. Was there any question online? Excellent. Thank you very much.
Thank you.